Hello everyone, welcome to Swiflearn, India's most sincere learning destination for classes 1 to 10. Here we provide you 100% live and interactive classes. We have a personalized attention batch with maximum 6 students only and a dedicated academic team to track and work on students' progress. We also cover school exam schedule and we also handle custom requests. So let's discuss some key features of Swiflearn. Here we provide detailed progress posts to the parents in which every learning parameter of the student is discussed in detail. And here student can also attempt Swiflearn academic test series, can take unlimited practice tests, and both are available subjective and objective. So what are you waiting for? Book your trial now. Visit our website www.swiflearn.com and don't forget to like, share and subscribe on our channel. So let's begin our new session 2nd of grade 9 area theorems. Area theorems already we have discussed in the previous session. Whosoever has missed the session, we will recall the area of figures and then we will recall all the theorems related to the figures, and then we will learn the new concepts: triangle with same base, vertex and base along with the same line. Okay, the session is going to be very interesting and it's very important session for grade 9. Before starting the session, let's define some important terms. So some important terms are base and altitude. So let's learn and let's have a revision. We have already discussed in the previous session what is base and what is altitude. A base of a polygon in one side of a polygon usually used as a reference side for the other measurement, and an altitude segment joining the vertex and perpendicular to the opposite side is called the altitude. Let's take a simple example of a triangle. So this is known as the base and this is known as the altitude. Okay, so I have already told you in the previous session that the altitude is 90 degree, that means it's perpendicular to the base, and there's a difference between a median and a altitude. Median divides the triangle into two equal parts. For example, like this: if a triangle ABC and AD is median, that means triangle ABD is equal to the triangle ADC. So this is median. If AD is a median, then it divides the two triangles into then the two triangles are equal. So these are some basic concepts. We are just brushing it up. So now how can two geometric figures can be on the same base and between the same parallels? Do you know? Okay, let me show you a diagram of a figure. Two geometric figures are said to be on the same base and between the same parallels if they have a common side as a base and vertices opposite to the base lie on the parallel line to the base. For example, if we have a parallelogram like this, A, B, C, D, and we have another parallelogram like this, this is D, E, that means they are formed on the same base and between the same parallels. So this is example of the figure. Two geometric figures are said to be on the same base. Base is same DC and between the same parallels if they have common side. Now they have common side and vertices opposite to the common base lie on the line parallel to the base. Okay, so let's proceed further. In the previous class, so what we have learned in the previous class? In the last class we have studied about the various theorems about the figures. So can you tell that theorems? Do you remember that theorems? Okay, let's have a revision again. So the three theorems which we have learned are as parallelograms on the same base and between the same parallels are equal in area. Very important here and very useful in solving the questions. Next, the area of a triangle is half of the parallelogram on the same base and between the same parallels. Third theorem, triangles on the same base and between the same parallels are equal in area. So we have learned previously these three theorems. Okay, so we were doing the revision what we have learned in the previous session. Now we are going to start about today we are going to learn about triangles with the same base, vertex and same so today we are going to talk about the triangles with the same base, vertex and same base along the same line. Okay, so today we will only talk about the triangles. So the given figure, this is a given figure, this is a triangle, everyone knows this is a triangle, and there is one line drawn between DB and there is one more line and it's named as H. The given figure shows that triangle ABD. Now this triangle ABD, triangle BCD, that means this triangle BCD, and triangle and the whole triangle ACD. So these are the three triangles. Okay, and what is the main thing with the same vertex? What is the vertex here? Do you know what is vertex? Yes, where the sides are joining at the points, two sides, so this is called the vertex. So the three triangles have the same vertex, that is D, and base along the straight line, and base is also same AC, same vertex and same base. So they have same height, that means they will be having same height, and we will take H as a height in this case. In this case, the area of triangles are in the ratio of their bases. That means in this case, when three triangles or more than that are joined with the same vertex on the same base, that means the areas of the triangle are in the ratio of their bases. Okay, is it clear? Okay, now area ratio. So ratio means in division, right? Area of ABCD, so we are taking this triangle divided by this triangle. So it will be AB and BC. Okay, so we'll put the names AB and BC. Their base ratio किसका होगा? उनकी base का ratio होगा, right? So we will write AB and BC. Now second, we will take the triangle ABD and the whole triangle. We'll take this triangle and we'll take this full triangle, and again the ratio will be of their base. So it will be AB upon AC, right? Okay. So let's next, because three triangles are in proportion, so area of ABCD. Now we are taking this triangle. Area of ACD. Now we are taking this full triangle. Again the ratio will be of their bases, and what are the bases? BC and this full AC. Okay, so we have found that when the triangles are on the same vertex and on the same base, their bases are in the ratio. Let's see an example. In a triangle ABC, D is a point. D is a point inside BC. Okay, D is a point such that twice BD is equal to thrice DC. Okay, so that means this is not a median, it's not dividing the triangle into two equal parts. Prove that the area of a triangle ABD. Now we have to prove that the area of a triangle this is 3 by 5 of the area of triangle ABC. Now what we have to prove, we have to prove the area of this triangle is 3/5 area of ABC. That means this full triangle. Now how we are going to use this theorem which we have just learned, how we are going to apply this theorem. Okay, so we have to prove this. So let's begin. Twice BD is equal to thrice DC. twice BD is equal to thrice DC, 3 times DC, right? It's given. It's given in the question. First of all, every time check what is given in the question and what we have to prove. Then we can go step by step. So this is given, and from this what we will conclude? We will conclude BD upon DC is equal to 3 upon 2. Correct? Now BD upon BD plus DC is equal to 3 upon 3 plus 2. Alright? Okay, let's see the next step now. Okay, what will be the next step? We have got that BD upon BC is equal to 3 upon 5. BD upon BC is 3 over 5. Since triangle ABT, now we know triangle ABT and triangle ABC have same vertex and they are on the same base BC. The areas of the triangle are in the ratio of their bases. This means the area of a triangle are in the ratio of their bases. So this means area of triangle ABD, this one, upon area of triangle this full ABC is equal to, yes, what is the base? BD of this triangle and this BC of the whole triangle, because we are talking about this whole triangle. Okay, is it clear? Now area of ABD, now this triangle we know upon the triangle of ABC we have just proved it is 3 upon 5. Okay, now it's easily solved that area of triangle ABD is 3/5 of the area of triangle ABC. So this is how we have used the theorems, we have applied the theorem in the questions so that we can solve it easily. Okay, let's try some more questions. In a question is that in a parallelogram ABCD, now we are taking a parallelogram ABCD and points Q and P lie on BC and trisects it. Okay, 3 हिस्सों में divide कर रहा है. Prove that. What we have to prove? We have to prove triangle, area of a triangle APQ is equal to the area of triangle DPQ and it's equal to half of the area of a parallelogram. So we will apply the theorems which we have learned previously in the question. Okay, so let's see how we can solve it. So though it's given, now first of all what we will check what's given. So it's given P and Q are the points on the BC, right? So what we will do some construction part. We will draw PR and QS parallel to AB. Now PQRS is a parallelogram and its base is PQ is equal to 1/3 of BC. Let's see. Okay, so we have a ABD and we points lie PQ and PQ lie on the side BC and trisects it. So we have to prove the two triangles are equal and hence their area is equal to 1/6 of the area of triangle ABCD. Now we are going to prove this. So we have done some construction. We have drawn the lines PR and QS. Okay, so we can name it like this, PR. So it will be like this, PR and QS. So we'll put S over here. So PQ is equal to 1/, this PQ is equal to 1/3 of BC. Okay, so let's proceed. Since APQ, now we have a triangle APQ, this triangle, and DPQ, this triangle, are on the same base, right? And between the same parallels which we have learned in our previous class. That means the area of triangle APQ and DPQ is equal. So we will put this equation as equation 1. Next, what we have to prove, since APQ and parallelogram PQRS, so we have put the point here, PQR and S are on the same base. Now again they are on the same base PQ and between the same parallels. What are the parallels? PQ is the parallel and AD is the parallel. Okay, so these are the two parallels are between the two parallels. Next, area of triangle APQ is half the area of parallelogram PQRS, because we have already learned this theorem in our previous session. We are just applying this theorem in our question. So area of a parallelogram PQRS upon area of a parallelogram EBD ABCD is equal to BC upon PQ multiplied by their heights. That is equal to 3PQ upon PQ. That means area of a triangle PQRS, PQRS, this one is 1/3 of the area of a triangle ABC and D. So this we have to prove, and this was using first and second. What here we have proved. So first we got half and then we got 1/3. So when we will multiply 1/2 by 1/3, we will get 1/6. That means the area of a triangle APQ is 1/6 of the area of a triangle ABCD. Hence proved. So just you have to remember the theorem and you have to apply it in the questions. Now try this. Try to solve. In a given figure ABCD, we have a figure ABCD is a quadrilateral. So what is basically a quadrilateral? Yes, quad means 4 and lateral means sides. So four-sided figure. So four-sided figure. It can be a parallelogram, it can be a trapezium, it can be rectangle, it can be square. With diagonal AC and BD intersecting at point O. So we have to prove area of triangle AOD is multiplied by the triangle BOC is equal to the area of AOB and COD. So let's see how we can proceed this. Okay, so first of all, whenever the triangles have their base along with the same line and vertices at the same point, then the ratio between their areas equal to the ratio of their base, which we have learned in the beginning of our session. So triangle AOB is equal and triangle AOD, let's see the ratio. That means area of triangle AOB and upon area of a triangle AOD is equal to BO and DO. Alright, between their bases. So what is the base? Base is BO and base is DO of these two triangles. Okay, sorry, AOB and AOD, these two triangles. Now next, again we will take the two triangles BOC and COD, in which we have the same base and the same vertex. So their ratio will be same. Area of BO will be equal to DO. Same. So now we will cancel out because in both the equation the BO is equal to BO is equal to OD. So when we will combine the equation first and combine the equation second, we will get they are in the ratio. And when we will do the cross multiplication, we will come to the conclusion that the area of AOD multiplied by the area of triangle BOC is equal to the area of triangle AOB and multiplied by the triangle of COD, because they are, this is on the left hand side and this is on the right hand side. We know when we will, this is in division, and when we will take this to the left hand side, division will be changed. The operation is changed, inverted. So division is changed into multiplication, and again division is changed into multiplication. So hence we have proved this question. Okay, so we have done lot of questions today. So let's solve one more question, and the question is about a median. So how to do this? In the given figure, AD is the median of a triangle ABC and E is any point on the E. So median, that means is dividing the triangles into two equal parts. So what we have to prove? We have to prove ABE. So this triangle is equal to this triangle. Let's see, area of these two triangles are equal. So let's see how we will solve it. It is given that in a triangle ABC and median AD and E is any point on AD. So it's given, first it's what is the first step? Whenever you have to solve any question, read the question and find out what is given and what we have to prove. So let's start with the things which is given, so that we can conclude what we have to, what question is asking, what the examiner is asking us to prove. So in triangle ABC, median AD, since median, I have told you in the beginning what is difference between median and altitude. So median divides the triangle into two parts of equal area. So area of a triangle ABD is equal to the triangle of ACD. So let's put equation first. Okay, let's proceed further. So we again in triangle ABC, AD is the median. So we have ED is the median, because if AD is the median, so half of it will also be the median. That means triangle ABD, this triangle is equal to the area of this triangle. When we'll subtract equation second from equation first, we will get this part. ABE is equal to the area of ACE after subtraction. If we will subtract this part from this whole, we will get this part. If we will subtract this part from this whole triangle, we will get this part, right? So hence it's proved, but after subtracting. Okay, so two parallelograms ABCD and EFCD on the same base DC and between the same parallel AF and DC. We need to prove that area of ABCD is equal to the area of EFCD. So let's see how we will prove. So it's very easy basically. So let's try. So you know about the corresponding angles. Yeah, if you don't know, in our recent updated videos, we have video on corresponding angles. You can check our videos from the Swiflearn YouTube channel. And if you have any doubt, so I will again repeat what are corresponding angles. In triangle ADE and BCF, we have angle AEE. So what is the triangle DAE? That means this triangle. 1, we will put is at 1, and triangle angle CBF. So CBF, so this. Okay, it's 2. What are corresponding angles are like this? So between the parallel lines, okay, and the one is like this. So these are our corresponding angles. One outer side and one inner side. Okay, and this Z makes the alternate angles. Okay, so we are not going to define it. So AED and BFC, so AEF, so this and this will be corresponding angles, correct? Okay, so we have put equation 1 and 2. So therefore ADE is equal to BCF, angle sum property of triangle. So we have proved that angle ADE. So what is angle ADE? AD, that means this triangle. Whichever name is written in middle, that means we are talking about that angle. So BCF, in which we are talking about the angle C. Okay, so by using the angle sum property, we have proved that they are equal. So opposite sides of the parallelogram AD and BC are equal, we know it. So as by the rule angle side angle, so it's divide angle side angle. How angle side angle? I will tell you again. So this is the property of congruent figures, congruency. So we have proved this by angle and this is by angle, and we have also proved this by side. So that means angle side angle, rule of the congruent figures, we have proved the true triangles are congruent. If the triangles are congruent, that means their areas are equal. So area of parallelogram ABCD is equal to the area of triangle ADE plus area of ADCB. ADCB, if we will add these two, it will make the parallelogram ED or EFCD, or we can write it EDCF. Okay, so hence we have proved it by using the rule of congruency. Now this is your home task. You have to do it at home or there, and write your answer in the comment box, or we will do it in our next session. Till then, I will tell you a very interesting fact about the triangles. Triangles come from the Latin word triangulus, three-cornered or having three angles. So this is a triangle. Okay, triangle is not easy like quadrilaterals because we have different type of triangles like isosceles, scalene triangle, equilateral triangle, and they have their different properties. So like square, we have only one type of square, so it's not easy. So from the roots, tri means three and the angulus means angle or corner. So it's a Latin word. Okay, so take care of yourselves, and first of all we will wind up what we have done. We will again recall the area of the figures. We have described what is base, what is altitude. Triangles with the same base vertex and same base along the same line, that means their area is in the proportion, right? And recall the theorems related to the area of figures. And we have also done so many questions, and I have given you one question for the homework. If you will, I will wait for your answers in the comment box. Do write your answer in the comment box, and we will meet in our next session. Till then, take care and don't forget to like, share and subscribe our channel.